Hey guys, Travis Gillespie here. In our last video, we looked at finding these angle sums, or the actual angle measures of isosceles, equilateral, and also scaling triangles. In previous videos, you looked at actually acute triangles as well, using the triangle sum formula. Now let's actually take it up a notch and look at a real-world application. So the most critical piece of this sentence here, grab a new pen, but the most critical piece here is the last sentence, and it says find the angle measure and draw a possible picture from it. So actually the most critical piece is to actually draw this triangle up. And in fact, I think that with every problem it's important to draw the problems. But let's look here. I'm going to just highlight the important information. So the first thing I know about this triangle is it is a right triangle. I'm going to have one angle that is 90 degrees, and then I have another angle that is half the measure of the third angle. So that gives me information about all three angles. So the first thing that I'm going to do is actually just create a right triangle. Just draw it up on the board as best as possible. It doesn't have to be perfect. This is your own drawing. It's not to scale. It's not a book. So I already know that I've got an angle that is 90 degrees. So that guy's 90 degrees. And then my other two angles, one is 1/2 of the larger angle. So one I'm just going to call x. I'm going to say that the third angle is going to equal x. And which one's the larger of the two? Well, in reality, here I'd look for the longer length and say the longer length side is going to have a smaller angle. But again, my triangle's not drawn to scale, so it's not as important which one I'm trying to figure out is larger or not. It just doesn't matter as long as I understand the concept. The concept is more important. So I'm just going to call this guy x right here. Say that he's a larger angle because his length looks a little bit shorter than this length. And since this length is longer, it's going to have a smaller angle. But again, it's not drawn to scale, so it doesn't matter. And the other angle I'm going to call half of x. So this guy is going to be half of x. But what do they actually equal? So let's call half of x is my smallest angle. But what's the formula? How am I going to write that up? Well, let's do that here. Let's just say, all right, well, half of x plus 90 equals 180 degrees. Cool. I can actually write degrees over here as well. So the next thing I'm going to do is let's combine like terms. Well, half of x plus x actually equals 1 and 1/2 x. 1/2 x plus 90, which equals 180. And the next thing I want to do is start to isolate the variables. So I'm going to subtract 90 from both sides. And I'm left with over here 1/2 x, or 1 and 1/2 x, 1 and 1/2 x equals 90. The next thing I want to do is take this mixed fraction and turn it into an improper fraction. So that would actually end up giving me halves x equals 90. And now to isolate the variable here, I want to get rid of the fraction. Well, the only way to do it is to multiply both sides by the reciprocal of 3/2, which would actually be 2/3. 2/3 times 3/2, and also 2/3 on the other side. These two guys are going to cross out here, and I'm left with x on the left-hand side, and on the right, you see here that, well, I have 30 now. 30 times 2 would be 60, so x equals 60. Well, 60 degrees x, that's our third angle here, so just plug in 60 degrees. And also, well, half of x would end up being 30, so the smallest angle is actually 30 degrees. You could go ahead and calculate this all out and check it by saying, hey, this holds true. 30 plus 60 plus 90, all of these degrees have to add up and equal 180, and they do. Cool. This is cool stuff, so have a lot of fun when finding out the measures or the unknown measures of your angles. Cool, guys. Have fun.